Okay, I would say let's start.
Yes, let's start.
Yep. So hey, welcome everybody to the meetup. Can you go for the next slide, please? So today meetup is going to be about introduction to Scapy, and this is basically is a Python packet manipulation library, and we will be showing you some use cases and going to be giving some introduction to the library. Next. This meetup is organized by NetBCN. NetBCN is a meetup group based in Barcelona, where we are organizing meetups about any topics related to networking. Our website is www.netbcn.cat, and we welcome you on our Slack, netbcn.slack.com. I would also like to thank Glovo for hosting us and providing Zoom as a meeting room. Regarding the format of the discussion, if you have a question, you should unmute yourself and just speak up. And at the end, we will be able to accepting questions over Slack in /general, and you can ask them in Catalan, Spanish, or English.
Yes, please. So I would like this workshop to be very interactive. So whenever you have any question, just stop us, Adam or myself, by presenting. And
yeah, just don't forget to unmute you. And once you ask the question, then mute yourself again, please, to avoid the noise.
Okay, so shall we start, Adam?
Yes.
Okay, so the agenda for today's meeting, it will be like a short introduction of what Scapy is. Then we're going to go into the very basics of packet manipulation and all the different tools that the library has. Then we will do a very short demo in which we're going to show live how this works. Then we will essentially show one of the use cases that I personally use in the company that I work for in Volta Networks, which is a data plane use case. Then Adam is going to speak about the use cases, several use cases in the security area, and he's also going to do a demo. So let's start with what Scapy is. Essentially, Scapy is a Python library that was designed for packet manipulation. So it can do packet decoding. It can also craft or forge any kind of packet. And it also very easily interfaces with the typical tools of sniffing and injecting packets. There is support for, I think, all of the operating systems one way or the other. So it's really widespread. And it has also a couple of cool features, which is on one side, there is this command line interface of Scapy that is based on the Python interpreter. So it's really easy to try out and compose and create packets and do some basic things. And then it's very easy to also integrate with common tools, as I said, pickup or any sort of sniffing technology. But also by the same nature of the library, which is made in Python, it can be very easily integrated in a Python program or script. So one of the that's actually, I didn't know that when we were preparing this slide set. I just didn't know how Scapy was pronounced. In Spanish or in French, it's pronounced as Scapy. Probably English native speakers would say Scapy from Python, but apparently because the original the original author and the maintainers are all French, they made this announcement in Twitter that we should pronounce it as Scapy. So that's what we're going to use today. So in terms of protocol support, again, I knew it had supported a lot of things, but when we were actually preparing this slide set, I was amazed of the amount of protocols that I didn't know, like GPRS or automotive protocols. There's a lot of protocols. I can say that, of course, there are probably missing protocols. I precisely found one that is not there. And you can use this command, which is ls command, to list the available protocols. But also the good thing of Scapy is that you can build your own protocols. So if you're building some system that uses particular encoding and you want to reuse the already existing headers, it's really very easy to extend, and you just use their framework, define your protocols, and you move forward. So at a glance, like very simple, you have you can use Scapy as a library in the left. So you're simply importing the protocols or the so-called layers in Scapy that you want to use. You compose the packet. We will get into the details about this later on. And you can write your own script and use it as that. Or you can use Scapy as a program that launches this Python shell. You can do exactly the same things that you would do with the regular Python interpreter. But in addition, all of this, let's say, includes or imports are already done. So you have them already available. So starting with the very basics of how to use Scapy. So in Scapy, all of the packets are Python objects. And so the way that you are creating them is by using the classes that define the protocol, for instance, Ethernet, IP, TCP. And then you use the slash operator to concatenate packet headers. In this way, you're building all the stack of protocols that you need for that specific packet, and the resulting object is a Python object. So with regards to the packet creation, as you have seen before, in the example before, I didn't really specify all of the fields of all of the layers in the packet. And this is because Scapy by default will put some reasonable values into the different protocol headers. In particular, if you have a stack of protocols, it will automatically put things like, I don't know, the ether type or the IP protocol, which already signals what is the next protocol that comes in the stack. It will also add some common defaults like a valid and quite common TTL, which is 64. And if you're not specifying things like the source IP or the MAC source, then it will try to deduce it from your computer, what the interface that it would typically use to get out if you're doing the routing. It also auto computes lengths and checksums, especially checksums. This is very handy. It's very tedious to actually compute that in any program, in any language. And it's really error prone, and you don't want to really do that. And then, of course, for the fields that you are not explicitly initializing, then you have to tell Scapy to explicitly initialize them, or it's also done when you're actually outputting that packet somewhere. That can be a send, or it can be a write to a pickup file that we will see later on. In particular, the show-to command is the one that will populate all the missing fields, will calculate all the checksums. And this is what we see on the right here. And essentially, it's exactly the same packet that we saw before. Simply all the rest of the stuff has been populated. In terms of manipulating existing packets, when you already have created them, you can copy them as any other object, deep copy them. You can essentially access any of the headers, and the way to access is using the brackets operator and using the name of the field, the name of the protocol. In this case, in the example, it's IP. You can use, as we said before, the ls command that is used also to list all the available protocols. it can also be used if you pass the specific protocol to see all of the fields in that protocol. So for instance, in IP, it will show the protocol, like the field version, IHL, TOS, LEN, etc. So you know how to actually access and modify those values. As we see here, for changing the IP source, the source is one of the values of the IP header. So really, there's no limit on what combination of headers you want to build, even if that would make absolutely any sense in any network. Scapy doesn't artificially limit that. You can create stacks that don't make any sense, and you can even try to send it. Of course, most likely some of those stacks will just not work. But this is particularly useful when you're trying to, for some security use cases in some cases, but also when you're trying to see whether some of the software that is actually doing packet manipulation, let's say firewall, let's say NFV, for instance, it's one use case that used to be very common 1 or 2 years ago. You can use that to actually make sure that the whole parsing of the package is correct. So another thing that, to be honest, I've never used much, but that is really, it's really cool, is that you can specify both a set of values or a range of values in some of the fields, or all of the fields, but in the fields of the different packet headers. And what it means is that actually, in this case, in this example, that we're putting a set of 2 IP addresses in the destination IP, and we're putting a range of ports in the TCP destination port. That means that the object P is actually not a packet, but a meta packet. And then when you're actually going to use it, for instance, to output it into an interface, or to output it into a pickup file, it will actually create all the permutations of the packets. And so this is even useful in some cases where you want to again test that the parsing is correct for all of the values and things like that. So this is Adam, you take it from here.
Yeah, this is for another way how this is about sending packets. So basically, Scapy also provides functions for sending packets on layer 3 and layer 2. So for example, for sending packets on layer 3, you would be sending using a function called send. And basically what you would just do, as you can see on the picture to the left, is that we are basically building an IP, basically an ICMP packet to 8888, and then we are just sending it out. This packet, I mean, you don't have much option, and in most cases the kernel will route the underlying operating system kernel will route this packet. But if you need to modify it on the layer 2, then you can use a send p function, where you would need to also provide the link layer the link layer, meaning the Ethernet or different layers, and you could define the source and destination. And for this, though, we will need to have a the root permissions on the systems. Mark, can you switch the slide, please? Yeah. Then way how you can, it also supports receiving packets. So there is a function called sniff. Sniff basically is what would happen if you would be running like Wireshark, meaning that you would be sniffing on the interface and you would be putting the device into the promiscuous mode. So for this, you need to have root permissions, and you can pass in some arguments. Some of them are like count, which you define number of packets you want to capture, or timeout, like number of seconds you want to be capturing for, and it will it will then provide you the packet dump from the network. And in the picture, you can see that we are sniffing on the interface we at 0, and we canceled it, and then we received one packet, and we are able to use the Scapy interface to manipulate with packets. So, for example, like convert it to the command.
Exactly. This is the command that will generate exactly the same packet as packet 0 in the capture.
Yeah. Next. Then there is a set of functions to send and receive packets on layer 3. So there are like functions like SR, which allows you to send and receive packets. You will also get unanswered packets, and this will basically return a couple of packets. I never understood really how many packets, but I used to use like the send and sniff, and these functions are like wrappers around getting the packets. So, for example, in the question in the picture to the left, we see that we are again sending the ping to Google DNS server, and we received 2 packets, but we got 1 answer. Scapy is intelligent enough to be basically able to match queries to answer. So, for example, if we are sending echo request to 888 and we receive a reply, then it is able to match them. Then there is another function called SR1, which basically is designed for cases where you want to send 1 packet and you are waiting for a reply. So this is actually something we are going to use in a security live demo. And SR loop is basically the same thing, but this basically only difference is that this keeps going until canceled. So if you keep it running, it is running. On the picture on the right, you can see that the SR loop sending the ping, and it is printing out the received responses, and I stopped it after 5 packets. And for SR1, you see that there has been the 2 packets received, and it was matched. Yeah, can you go for the next slide? Yeah. So what we have for layer 3, we also have for layer 2. So here we can see a function like SRP, which is basically the same thing as SR, but for layer 2. SRP1, the same as SR, but for layer 2, and SRP loop for layer 2. On the example, for example, this is something that which I'm trying to determine which hosts are alive on the network by sending rping request. Next. Yeah. Another pretty cool stuff about Scapy is that it allows you to generate packets, and then you can actually write them to a pickup, and you can also read from a pickup format, which is quite handy. Which, for example, I used to use in cases when I needed to generate certain packets and I wanted to launch them on a network, but I wanted to do them, for example, from a packet generator, which is much more performant. But I use Scapy to generate the packets. So on the example, on the picture, for example, you can see that we are defining the packet, we are writing it to a pickup, and then we are reading it again, and we are basically getting the same response. Next. Another interesting thing about Scapy is that, as Mark mentioned, it has a support for a lot of different protocols and contributions like BGP and MPLS. So there are some headers defined in contrib Scapy package, but they have to be manually imported even from Scapy CLI. So the idea is that you would be able to find protocols about BGP, HTTP, LACP, LDP, and multiple routing protocols. What is actually interesting to know is the function called ls, which will basically display all the available protocols. And if you want to do this the same thing with the user interface, then you can actually use explore. And I think Mark will be showing this in the live demo. Can you go next? Another interesting thing is that sometimes you need to use certain well predefined or well-known functions. So for example, ARPing, what I was doing previously, but the Scapy comes in with a built-in commands. So for example, if you want to check if the host is alive on layer 2, you would be using ARPing function. Basically, it handles all the packet building and handling the responses, sending the packet, and so on. You can also check different different things. For example, if you want to test the DHCP, you can basically create a DHCP request or dynamic DNS updates. Yep. And now Mark does the demo of live.
Okay, so I'm not sure if someone has a question at this point. Please, if you have any question, unmute.
Speak up.
We're going to now do a simple demo. So we have here the Scapy CLI. We started it with sudo. For the purpose of the demo, I've also set up a pair of VTHs, which are virtual Ethernet interfaces in the Linux kernel. And the only reason why I did that is so that we can inject traffic and we can capture traffic without all the background traffic that there is in my real interfaces. So at the same time, I'm going to start the TCP DAM on this interface. Okay. The thing is, I'm starting this TCP DAM with some flags to see also the layer 2 packet so that we can see all the things that we're generating. So the first thing is I'm going to show this command that Adam was talking about, which is explore. It seems that it's not working because I don't have the Python installed. I will show it afterwards when we are not in sudo, because I guess this is an environment problem. The way that you build packets in Scapy is, as we said, you are defining your header and with the values that you want to use. Okay, in this case, a source MAC. Okay, we're not going to put destination MAC, and you start to stack protocols one after the other. If you're particularly interested in something, for instance, the destination port, then you use, then you would put it here. If you're not interested, you just leave it here. So once you have this, this object, you can use all the things that you typically use in Python. So for instance, the operator length, you can see what is the length of the packet. Okay, if you are actually printing the object, it's going to only show you the values that have been defined, in particular, the source MAC, in this case, the ether type and the protocol, because we haven't said anything else. So what we can do now is we can essentially inject this packet in the interface, okay? What's going to happen is obviously it's going to send us the packet. It's here. There's a little bit of IPv6 background noise here. But as you see, it has populated all the different fields. For instance, in the source and destination IP addresses, has put the loopbacks and so on. Okay, and if we want to see what is the auto completion that it's doing, we can use show2 to see that. Another thing that we can do from the CLI, but also as a library, is to essentially from the same Python script that we're building, we can XDAM the packet the same way that you would see it in Wireshark. Okay. At the same time, if you're using some other tools, you can convert this into the raw hexadecimal in case you would need it. And this is particularly useful if you're using different tools like traffic generators and so on, in which the formats, most of them except PCAPs, but some others would ask for instance, the hexadecimal representation, things like that. Okay, what I'm going to show you now is also how the whole range of values work. So for instance, we're going to define that the destination IP address is 8.8.4, sorry, 8.8.8.8 as one of the possibilities. We're going to do a set, and we're going to send it also to 9.9.9.9. And we're going to output this packet again into the virtual Ethernet, and you will see that this results in two different packets. Okay, one destined to 888, the other destined to 999. So this is particularly useful also for some of the use cases that Adam is going to speak. Now we're going to show how the sniffing function works, which is pretty simple. You use, as we said, the sniffing function here. You indicate which of the interfaces you want to sniff. In this case, I'm going to use the VT80. And you can put a timeout. Let's put 10 seconds. And what I'm going to do is inject some packets, which will only be essentially ARP requests, because I haven't really configured any IP address. We see them here, and now the packets have finished. The sniffing capture has finished, and we can use again the typical tools that you would use in Python, like the length of the packets shows us 2, and also the operator as if it was an array of packets. And we see that this is exactly the packet that we injected, the ARP request that we were seeing in TCP/RAM. And as usual, we can go here and say, okay, perhaps I want the ARP, just seeing the ARP, or I want to change a field and copy it and use it, perhaps modified. And this is the way that you are actually forging packets in the way that you want. So that would be all from let's say very, very simple and very basic tutorial of how to use Scapy. Of course, all that we've done here in the Python CLI can be used from a Python script or from your application in Python, which is what is particularly handy also. So,
excuse me, Mark.
Mm-hmm.
Hey, this is Peter.
Hi, Peter.
I have a question. Is there any documentation or that explains what the keywords are for the protocols, or is this just all standard PCAP?
So, so you mean the value, so the name of the fields and things like that?
Like in your when your screen right there now, like a few lines up, you have P equals ether, you have source equals MAC address.
Mm-hmm.
What is there documentation that explains?
Yeah, so
you can use source SRC.
Yeah, you can use LS to show all the protocols, and there are a lot. Okay, and then if you want a particular protocol, say IP or Ethernet, I think you were saying, then you use this, and it will tell you what is the name of the field and the length. And this works for all of the protocols. So because the framework that Python builds has this metadata of how many fields and what is the length and so on, you can always get this. You have this introspection capability built in Scapy.
Okay, thank you. One other question.
Mm-hmm.
The hexadecimal output, is it possible to import hexadecimal into Scapy? Okay.
Yes, we can do it if you want. So I will import Vinasky. Vinasky is some tools that are doing binary manipulation, and we can do, for instance, can get the bytes of the packet, okay, and this will generate us let's say the hexadecimal string, let's say, and you can import it, for instance, from this hexadecimal by just doing the reverse operation exactly, which is, we can say, okay, the packet is Ethernet, you have to tell which is the base protocol, okay, and then you can do exactly next define, and then you put the string. And by the way, this is something that I personally use sometimes, because one of the tools that we have, is expecting this sort of input. So so I'm using this WinASCII, XLify, and XLify pretty often. And by the way, this output can also be copied from a regular Wireshark. So if you can copy from the Wireshark with right click, you can copy all the bytes that are in the packet in this format also.
Okay, thank you.
Welcome. Is there any other question? Okay, then we jump into the use cases. So
Yep. So the security use cases. So Scapy is very flexible and it's very handy for network security engineering. So some of the use cases I saw people using in the using or I used in the past. So for example, pretty useful for recon. There are a lot of tools, maybe better tools like Nmap or different scanners that are focusing on scanning, but they're pretty well known. So for example, they will be detected. So the idea is that if you would like to avoid being detected, maybe creating your own scanner could be an option. So you are able to use Scapy to basically build one, and you are able to determine exactly what you need. So for example, you could be checking if the port is alive or if the host is alive, and so on. Another interesting use case is the infrastructure penetration testing. While you want to, for example, see how the devices are responding to certain packet combinations. One of the examples I read about in the past was that there were some switches that have a very weird VLAN handling, and you would be able to use the so-called VLAN hopping, meaning that you would just prefix the packet with the VLAN header, and you would be able to inject the packet in the particular VLAN, meaning that the implementation was not properly tested or was not properly handling certain cases. And then another use case would be like firewall configuration testing. So let's say that you want to have a complex firewall setup, but you want to test it, and Scapy provides you you could have actually automate the setup with Scapy just by generating the packets, the destination IPs, and all the combinations you can think of. Mark, please switch the slide next. So in the security live demo, so basically we will be doing a very simple port scanner that will be determining the status of the port. This is a technique basically taken from Nmap. This is basically something they called like stealth scanning or SYN scan. So the idea is that the attacker, the CRAT, will be sending a SYN packet to port 22 on scanme.nmap.org. The machine will respond with SYNAC, and then the attacker will send RST, meaning that he wants to cut the connection. But the fact that the host responded with SYNAC means that the port is open. Yeah, and this will be the basic example. So now I will show. Let me share the screen. So I did it before, but the whole idea is that I've wrapped the. First of all, we need to start with defining the source port. So Scapy provides a function called run short. Let me do it like this one. So I run the Scapy shell, and let's say that I want to generate the random source port. So every time when I try to access it, I get the random port, which is just good enough for our use case. Then we would like to build and scan for the TCP port. So basically, we would define a payload. Then we would concatenate them with the / operator, and we would be sending the packet out via SR1 function because we are interested basically just for the one response. Once we receive that one, we send the packet with a reset flag set, or we send it, and if the response has TCP flags contain the SYNAC, then we claim that the port is alive, and otherwise it's dead. So there is a site called scanme.node.org, which basically allows that to be tested for scanners. So what actually happens is that the Scapy created a packet, send it out, detected that there is a SYNAC, and based on the information, we determine the status of the port. What is particularly interesting about this is that this is extremely basic, but this gives you a lot of flexibility, because you could be defining contents of the packet, the payload. For example, you could include different. For example, let's say that you are scanning HTTP server. You could be including different headers. You could be different attributes of the packet, and this is one of the strongest point of Scapy, meaning the flexibility which gives you. I don't know if there are any other questions, or if you want to try something, because I think this is just pretty simple use case. But the idea is that in just matter of few lines of code, you are able to create something that's able to help you in your day-to-day job. If you need to automate, if you need to test, or if you need to do some security assessments. If not, then I am passing the word to Mark.
Thank you. So in terms of essentially vendors and people who are writing software for network equipment, and that can range from basic CPEs to firewalls, to switches, to routers. All of this, Scapy is very useful in several situations. One of them is essentially to test the behavior of forwarding of routers, of switches, and even on firewalls, as Adam was explaining, firewall configuration, even as a user, to write the proper rules and to make sure that there are no holes, that there are no ranges that are incorrectly filtered, can be tricky. And one way to make sure that this is correctly built is to just build a test that actively tests for these sort of things. Another useful thing, and again, Adam also mentioned it, is to program traffic generators. Some of the traffic generators that we usually work, at least that I personally have worked with, they require to set up for particular tests, like specific tests that you want to do, to provide a pickup with the packets, and so it's very simple to create a small script in Python and Scapy to build those packets, matching your criteria for the test. And finally, this is very important, is that for negative testing and fuzzy testing, understanding, well, let's try to break the thing. Scapy is also very, very useful, specifically for what we mentioned before, which is that it gives you absolute freedom to build the packets with the values and the combinations that you want. Okay, we can jump to the next one. So here is, well, a typical use case, and where we personally use it in the organization that I'm working with, in Volta Networks, to do basic unit testing of our devices, and in particular the forwarding device. So what we have here in the left is a white box switch, in which we're actually adding the software on top. And in this particular scenario, which is very simplified, what we're trying to validate is that the actual programming of the ARP table and the REAP as high-level concepts is correct, and that the device is routing correctly the IP packets. So what we would do is we would connect that physical switch to a server, two interfaces to the two different ports. We would build a small Scapy program that on one side, through the RPC or through the CLI even, whatever, it just sets that intended forwarding state. So the RIP, we're saying 8.0/8 go via this next hop, and then we program the ARP table. You can imagine a more complex use case in which you don't have a fixed ARP entry, but that you expect that to be resolved, and then Scapy would also inject the ARP replies to kind of train the router to properly forward the packet. And then the test is very, very simple, in which we are injecting a packet, Ethernet in this case, IP. Whatever it goes after that is really not applicable for this test. And then we are directing the packet to the MAC address of that port, of that reception port. The source MAC address is really not important, but what it is really important is to make sure that once the packet has been routed, the destination MAC address conforms to your neighbor MAC address, in this case 172.16.0.1, okay? That the source MAC address is also correct, and it's your own MAC address on port 25, 19 is 25 in hexadecimal. And very important, when you're doing IP routing, the TTL is decremented by 1. So these two values are in green to show that these are particular conditions that you have to test. And you can even check that explicitly that the switch will not be mangling any other field, in particular the destination IP address or the source IP address, or any of the bytes that are important in the payload. So this is one way of using Scapy, and it's very useful. We're using extensively with tests that are way more complicated, in which you have to train the system. You have to inject the packets first. You expect certain amount of packets. For instance, for layer 2, you're not expecting replicas. You're not expecting unintended VLAN manipulation. So it's really a great tool for this kind of job. Okay, so we are almost at the end. Some additional references. There is a great introduction to Scapy in this link, and also sometimes it's useful to have a look into the repository itself. It's really not that necessary if you know all these commands that we talk about, DLS and the explore and so on, but sometimes in the past, like a couple of years ago, there were still some bugs, and so sometimes necessary to have a look. And one last thing, at least from our side, please, we welcome you to join us in NetBCN so that we can continue talking about technical and non-technical network-related topics. So feel free to join us, and that would be it, I think. I don't know if there is any question with regards to the use cases or Scapy in general. Adam, can you go to the next slide? Yeah, right. So thank you. I don't know if you have any other questions. Adam, any other comments, questions?
Nope, not from my side. Well, we can check Slack if somebody raised the questions, but so far no questions.
Okay.
Perhaps this is Paolo. Perhaps I have a question. So first of all, I wanted to thank you both for this introduction to Scapy, because before this idea of the workshop, I didn't know about it, and I was still probably a few generations back, just making my C program and creating my own packets and things like that. And I have a great use case for this, which is actually testing a lip pickup collector So fantastic stuff. And the question is really a tangent on Scapy. So do you know if there is any, upper layer application based on Scapy, like, to generate traffic? Like, I don't want to say something similar, to all the advanced and beautiful features of Spirent, because that goes also in the application, but whether something upper level exists where, for example, if you want to test a cache of flows, so you just want to create a lot of flows and things like that, whether that already exists or you have to code it yourself.
So to be honest, I'm not aware of anything like that. I know that there are several projects that use it internally, but like for the specific use case that I told you, I suspect some companies have something like that. But I'm not aware. That doesn't mean it doesn't exist. I don't know.
Cool. So it will be nice research after this session. Thank you.
Hello, this is Costas. If I may add a comment here. Excellent stuff. I had seen, to be honest, Scapy a few years ago when a vendor had implemented a lightweight 4/6 solution. One of the things I talked in NetBCN, and I think, Paolo, that you can achieve what you want by generating the flows from Scapy, saving it in a pickup file, and use something like Snab, for example, to replay this pickup file at huge line rate speeds, utilizing full 10 gig links and stuff like that. But if you go for Snab, for example, Snab is one solution. Perhaps Cisco's VPP could also be used for that. But I guess you would need some sort of driver, a card that is supported by these tools. But in this case, you would generate your flows from Scapy and then replay it with a high data rate, let's say, even line rate for certain cards. This is.
Thank you, Costas. And by the way, on the chat, Martin, he already posted something that it seems there is a tool. I didn't investigate, but he says it's called the T-Rex, and it seems it comes from Cisco.
But so maybe that has changed. But as far as I know, T-Rex is again taking as an input pickup. Maybe that has changed. In the past, I know this DPDK-based traffic generator, and as Costas was explaining, you can always import via pickup.
Yeah, totally.
But maybe they have integrated. I don't know. Maybe they have integrated Scapy. I will have a look. Martin, are you still here or?
Yes, I'm still here.
So do you know if there is a direct fit in the sense that you can put directly the Scapy commands into the
tool? Yes, you can do actually both. You can use PCAP, but the PCAP is just in the idea to load your basic information, and then internally Scapy is used to do ranges, to do different IP addresses, because if you want to generate streams, you want to have multiple different IP addresses, destination addresses, source ports, etc. And the PCAP file is only used for skeleton. And then with Scapy, you are filling all the different parts which you want to randomize. And you can use T-Rex in that mode, but you can also use it in a single burst modus, where you just describe the package via Scapy syntax. And just really say, I want a packet with those kind of information, and then send 1,000 of those.
Cool. I don't know how advanced it is, because I don't know if you're familiar with tools like Spirent and so on, which they do all sorts of validation and emulation of a lot of clients and so on. I don't know if it's so advanced to reach that point. Do you know that?
I mean, I don't know the Spirent. I do know the Ixia quite well, Ixia network and Ixia load. It's more comparable to an Ixia network. but you can't do all the protocol ideas. You can't really start a BGP session. You can't do like all stateful stuff. So it's just a packet generator. It's a stateful packet generator. It has some form of capability of doing BGP route injection, but I never used that. But on this area, it's really limited. It's really packet generator, but it's really high speed. You can generate 100 gig with common hardware, and I think that's the important stuff for that.
Right, right, very interesting. I mean, I had looked at T-Rex maybe 4 years ago, and so I was not aware of these changes. So thank you for that.
Yeah, you're welcome.
Someone else, comments, questions?
Feedback.
So I guess we're wrapping it up.
Yeah, I mean, if people still have questions, I mean, unless there are any questions now, we are still taking questions over Slack. So, I mean, you can always ping us there. So then let's wrap up the session, and thanks everybody for attending.
Thank you very much.
Thank you very much.
Thank
Bye-bye.
you. Thank you
Bye.
for everything.
See you
Bye.
guys.
Thank you. Bye.
Right.